Hello everyone, welcome to StudyMate's physics class one more time again. So you remember we talked about the effects of forces. So I think everybody understood this part of this physics. So now from today on, we will start learning about moments. As well as, so what are the moments? Moments as it can cause two objects to speed up, slow down, change the direction, or deform. They can also cause some forces to rotate. For example, here is force causing it to rotate. You can see. So this is also a force because the weight of this object is forcing it to rotate. So an example of rotation caused by force is, as I mentioned right now, and this rotation can be clockwise or anti-clockwise. For example, here this is called no resultance force. So if it is like this and goes this direction, as you can see, it's clockwise, and otherwise it is anti-clockwise. So moments defined as turning effect of a force about a pivot, because as you can see here, about a moment, and it is turning this object to somewhere, either anti-clockwise or clockwise. The size of a moment is defined with this equation. So as we can see here, size of this moment is defined with this equation. So we can say that, so since m equals f times d, we can find f, which is m over d, and we can find d from this formula, which is equal to m over f. So you can derive all of these formulas from just one this. So in this equation, m means momentum, and this is calculated in newtons times meters, since f is calculated in newtons and d is calculated in meters, and f is force, the perpendicular distance of the force. Remember, it is not the just distance, it is perpendicular distance, because whenever force is applied from any distance, we are getting the distance that is perpendicular distance to the pivots. For example, in this case too, we have this object, and the force is being given by this place, and we are not getting this as our distance. This distance, the formula, we are getting this distance. But if we have this and this, we can calculate this. For example, let's call this A, and this thing, calculating this side is also very useful during exams. Since this is 90 degrees, because this should be perpendicular. Since it's 90 degrees, when we calculate this angle, for example, this angle can be calculated by sinus of alpha equals to the opposite side, which is b, and one in the hypotenuse, which is a. And since we can calculate alpha degrees using calculator, we can use it to calculate c. But do not around until you find the solution. Leave this alpha's value in your calculator and use it for calculations. And now cosine of alpha is equal to adjacent over hypotenuse. So we can use just this formula. we find A from here, use A to here. To find C, we'll use to find C, we will use B times, this is not minus, just typo. Then this would be formula to find a perpendicular distance to the pivot if it is not given. So this way, this is why, for example, door handle is placed on opposite side to the things, so that we can give our full force to the object in a perpendicular motion, so we don't use any other force that can be wasted. And that's why if you try to open the door from a lot of distance, for example, this is the door key, and if you do it from here, it will be much more easier than compared to here, where we have much less perpendicular distance to the pivot, because if we have much more perpendicular distance, this means we have much more force. So some other examples could be using crowbar to open pries of something. This is also same. You can, if it is given, force is given from here, it is much bigger. It leads to much bigger momentum than compared to here. Also scissors. That's why scissors. When scissors have much distance, it would be much easier to cut anything. So now principles of momentums. So principle of momentum states that if an object is balanced, the total clockwise momentum about a pivot equals to the total anti-clockwise momentum. So since we had this m equals F times D, and we calculate total anti-clockwise, we will add all of the FDs to here that are anti-clockwise, and all of the clockwise ones, FD, and then M anti-clockwise should be equal to M clockwise. So this is what principle of momentums states. So here, as you can see, now this is an example for us to solve. You can pause the video and try to solve this. And now I will start explaining it. So in this case, the adult sits this calculated distance. The child must sit on the pivot for seesaw to be balanced. So as you can see, this is our pivot from where we should be calculating the perpendicular distance. So this is the clockwise forces. This child is the only clockwise force, and the woman is only anti-clockwise force. So anti-clockwise equals to 390 times 0.3, and this should be equal to this child's power, this child's force equal to 690. Child's power times distance, and we need to calculate the distance, and here we will use this 390 times 0.3 divided by 140. So now we can use calculator here. So 390 times 0.3 divided by 140, which is 1.48. So as you can see here, we will get this value. If the child sits in this place, the pivot, the system would be balanced, seesaw. They can play seesaw game. So if you confuse while seeing this, which type of motion is anti-clockwise or which is clockwise, you can just try to remember this, or you can use clock methods while you will think. If this is going this direction, it's clockwise. If this is if this is going in this direction, it's anti-clockwise. Principle of moments, extended version. So as you can see here, as I mentioned before, there can be some more examples with more forces here. Like this system, if there in any type of forces, so only one thing we need to do, find all clockwise and anti-clockwise to the both sides and add all of them. When we add clockwise all the clockwise, it should be equal to all the anti-clockwise forces. So here in this example, this is going clockwise, whereas this is going anti-clockwise. So the only anti-clockwise forces F1, this, and this force F3 is going upwards, which can be go like this. This is also anti-clockwise. The only clockwise force is F2 times only this force, and its distance is D2 and F2. And when we multiply this should be equal to F3 times D3 plus F1 plus D1. So here, hence we can derive this from the two. So now, equilibrium. So the term equilibrium means objects keep doing what it is doing without any change. For example, if this leaves like this could be also one type of equilibrium. This is also equilibrium, as you can see, because this is not changing at all. There is no turning effects. So therefore, if object is moving, it will continue to move in a straight line without any acceleration. If it's stationary, it leaves stationary. If it's stopped, if it was turning, it will keep turning. This means equilibrium. So, as you can see here, some of the examples of where equilibrium is showed. So here, as we can see, this car is in equilibrium because it has this air resistance which is stopping this car from getting accelerated, and there is thrust which is causing it to accelerate. But if we add two of but if we see the two of them are equal, why can we say that? Because it has constant speed. Where there is constant speed, there is no resultant force. So in the second example, so this is this pivot is staying without staying stationary without any turning effects. So we can say that this is this is a balanced moment due to principle of moments. So let's solve this example. The diagram shows beam that is secured with a pivot at one end. Vertical force acts on the beam as shown. That holds beam in equilibrium. Calculate the weight of the beam. So we can pause the video and try to do it yourself. This is the pivot from one point. So all one type of forces are one type of force. This. The second type is this. So 10 times 0.2. Sometimes you don't have to analyze which are anti-clockwise or which are clockwise. You just have to see that ones that go to the same direction. For example, if this car, there is no it's anti-clockwise or clockwise, which there are two types of forces which can cause to accelerate and others to decelerate. So that's why in this example too, we don't have to analyze which are anti-clockwise and which are clockwise. So 10 times 2 equals to 3 times beam. Weight of the beam. So we can say weight of the beam. The weight of the beam equals to 10 times 2 over 3, and which is equal to 20 over 3. And also which is equal to 2 over 3. So we can split the also if it's asked in 3 forms, we can say 3, 6, 7. till now, demonstrating equilibrium, a simple experiment to demonstrate equilibrium. And so some of you might not think that equilibrium actually exists, but we can actually prove it using Newton meters. As you can see here, they are doing experiment where there is putting a pivot and they are putting some weights here, F2 to F1, and they are calculating these forces using Newton meters. And when they see this, that amazingly these forces are equal, which means that equilibrium exists, and this principle of moments can be used in real life too. So if you really want to do this experiment, I will leave the link to this more detailed setting up experiments so you can try it yourselves. Doing this experiment helps you to understand that the balanced forces, how the balanced forces really work, and so you can change these places and see that how balanced that they get and tuning effects. So goodbye. In the next lessons, we will continue learning about moments, center of gravity, investigating center of gravity. Goodbye, and I'll see you next time in StudyMeet's physics class.